Now, students, see experiment number 4. Using a meter bridge to verify the law of combination of resistances. Here we are going to verify law of combination of resistances for series combination. Now, apparatus required, you see, we are having our meter bridge, resistance box, two different resistances, two different wires of different resistances. Say resistance of this wire is R1 and this wire is R2. Okay, then two resistances, galvanometer, key, eliminator, which is connected with power supply. For series combination, what to do? Here I am joining these two wires in series. Okay. Now, come to theory. We know that when different resistors are connected in series, if one is R1, another one is R2, then equivalent resistance will be R1 plus R2. Now, we will use this circuit diagram. Here you see meter bridge wire AB, resistance box R1, R2, they are connected in series. Between these two we have connected galvanometer. One end of the galvanometer is connected with jockey. We are having power supply with plug key. Okay. Now we know that balance point for balance condition for Wheatstone bridge is P upon Q is equal to R upon S, or S is equal to R Q upon P. Here you see, for P we are considering this distance AJ, that is L, length of the wire L, and for Q it is rest part of the length 100 minus L, it is for Q. Substituting the values, we can get S is equal to R into 100 minus L upon L. Now, observation table, you see, after substituting the values for different observations, we can get S. Okay. Now, here one more thing we'll do. Since we are knowing resistances of these two wires, okay, first R1, if we are having, see R1 here, R1 and R2, they are connected in series. So, knowing the values of R1 and R2, we can get RS, series equivalent resistance R1 plus R2. Now, after observations, okay, after getting a number of observations, we will take average S, okay, and we compare with theoretical value and experimental value. Okay, theoretical value we are knowing, and experimental value here we are getting from our experiments, and then we will calculate percentage error. Now you see these two different resistances of known value, R1 known value, R2 is another, we are having some known values, they are connected in series, and same arrangement is here. Now when we put our key, then one end will show deflection in one direction, now deflection in another direction. Okay, so what will happen? And if you get deflection in same direction, means your connection is wrong. Okay, so be careful for this, be careful for connection. Now getting 1, 2, 3 for different values of R, we get different values of L and 100 minus L, so that we get here S. Substituting the values, we can get S. Okay, and average value of S we will calculate. Then what to do? We are knowing our equivalent resistance, okay, R1 plus R2. After our experiments, after a number of observations, we will compare with experimental value and theoretical value, so that we can verify the law of combination of resistances when they are connected in series.